Welcome back to A320 Knowledge, your trusted source for Airbus expertise. Today, we'll be diving into part 8 of our tutorial on the overhead panel. The A320 has hundreds of different buttons and switches, and we'll be tackling each of them section by section. In today's tutorial, we'll be focusing on the fuel panel. The A320 family's fuel system varies depending on the variant, but today we'll cover the fuel panel on a standard A320ceo aircraft. Let's start with the pump push buttons for the wing and center tanks. These pumps transfer fuel from their respective tanks to the engines. First is the wing tank pumps. Each wing tank has two pumps. In its default lights-out position, the pumps are operating and supply fuel from their respective wing tanks to the engines in accordance with the fuel feeding sequence. When the pumps are turned off, a white off light illuminates and the pumps are de-energized. An amber fault light will illuminate if the fuel delivery pressure drops while the pumps are supposed to be running, unless the pump is already switched off. Next is the center tank pumps. In their default lights-out position, the center tank pumps 1 and 2 automatically operate when the center tank contains fuel, provided the system is set to auto and in accordance with the fuel feeding sequence. See our other tutorial on the fuel feeding sequence for an expanded explanation. The center tank pumps deliver fuel at a higher pressure of 32 psi compared to 25 psi for the wing tank pumps, ensuring that center tank fuel is used first. If the slats are extended and the wing tanks are full, the center tank pumps will not run in auto mode to prevent overfilling of the wing tanks. If the center tank pumps are turned off manually, a white off light will illuminate on the push button and the valves are closed. An amber fault light will appear along with an ECAM caution when the fuel delivery pressure drops when the pumps are expected to be operating. If both center tank pumps fail, the entire center tank becomes unusable since gravity feeding from the center tank is not possible, as the center tank electric pumps feed the engines directly. Next, we have the mode selector push button, which manages the transfer of fuel from the center tank to the wing tanks. In the default lights-out position, fuel transfer is automatically controlled. The transfer valves open when the inner tanks drop to approximately 500 kilograms below their full capacity and close when the tanks are full, or 5 minutes after the center tank reaches its low fuel threshold of 130 kilograms. When the push button is in the manual position, the crew takes control of the transfer by manually opening or closing the center tank valves using the center tank pump switches. This mode is rarely used, but provides full manual control if needed. If the left or right wing tank drops below 5,000 kilograms of fuel while the center tank still contains more than 250 kilograms, an amber fault light will illuminate, indicating a failure in the automatic transfer logic. The crossfeed push button controls the crossfeed valve, which allows fuel to flow between the left and right-hand side of the fuel system. In default lights-out position, the crossfeed valve is closed, ensuring each engine is supplied by its respective wing tank. When the push button is selected on, the crossfeed valve opens, allowing fuel to be supplied to both engines from either side if needed. This is typically done to correct a fuel imbalance or during single engine operations. A green open light will illuminate when the valve is fully open. If the valve fails to reach the commanded position or malfunctions, there is no amber fault light on the push button. However, the crossfeed valve condition can be inspected on the fuel system display page. Thanks for tuning into part 8 of our tutorial on the overhead panel.